Bacon, sausages, egg, little rice, and 1 piece of bread. Nice. Wait, my stream is live. Come on, there you go. Okay, now you're working. Also, one sec, let me make sure my camera... Dude, they keep updating this camera software. It's super annoying. My camera looks a little bit weird. No, it should be okay. I think sometimes the exposure fucks up. There we go. And I gotta, like, boost this brightness. There we go. Okay, that's better. And then sometimes the white balance is weird. They make me, like, yellow. Okay. Cool. Jeff, don't worry. Next week, you might have some calculus questions. Wow. All right, let's see. Using energy level diagrams, explain how a solar panel generates electricity and how it relates to ground and excited states. Oh, wow. That's a cool question. Solar panel. I mean, from what I remember, like, solar panels take photons from the sun and then they force electrons to, like, go up in energy levels, which is kind of unstable. And then I think they move back down. I mean, let's find, like, a diagram of this. I mean, it's kind of chemistry. Yeah. Let's see. Solar panel. What do we call it? Solar panel, energy levels, electrons. Got a diagram? Yeah, there we go. That looks great. Valence band? I don't even... Dude, this is a little bit too complicated. Monkey Man says, the university I'm applying to transfer to sometimes does an interview. Interviews are great. Yeah, I love interviews. Yeah. No, I don't know if you can beg for an interview in your resume, but I agree that they're great. Yeah. Uh-huh. Maybe this is what we want? I'm trying to think, like, what type of diagram you want. Looking big, bro? What's up?
Good job!
I am big, but not in a good way. I need to get back to the gym. I spent the last 2 weeks not going to the gym because I was in Japan. I will start going back today. Y'all ever ask where breasticles, where his name come from? Okay. I can kind of, like, believe this. This looks decent. Ever seen the guy make a solar panel with a raspberry? Or the purple ones that look like raspberries? What are the purple fruit? Like blueberries? Blueberries are kind of like purple, bluish. Okay. Yeah. From what I know, sunlight in the form of photons will end up knocking off electrons. Like this. So here you go. All right, so when you have an incoming photon that is hitting one of the electrons in the atom, that will cause it to go up to an excited state. And then once it's excited and it's free, I believe you have, again, you have like these different junctions. You have like semiconductors, which kind of conduct electricity, but also kind of don't. N-type means there's a excess of negative charges. P-type means an excess of positive charges, but there's not actually positive charges. These are actually called, electron holes. It means like there's depletions, like electrons are missing. But the effect of having missing electrons is the same as having like an imaginary positive thing there. How do I know so much about everything? The internet. What's up, Jorge? I've also taught a lot of different... I think it's fun to like learn... Even this, like I don't remember all this, but you can go through the internet and like relearn it. What's up, Justin? Long time no see, dude. What's good, dude? Dude, Dude, every time I talk to
Okay.
you, your voice gets like deeper and deeper. It's like it's fascinating to like
don't-
listen to puberty
Yeah,
like over the last 3 years.
Nah, for real.
Your voice is gonna be deeper than mine by like next year.
Probably. I don't know.
Nice.
I'm just watching Ted right now.
Cool. That's a good movie.
All right. No, now I'm watching the series right now.
Oh,
The
there's a
2024
series? There's a series
Yeah.
for Ted? Oh, that's cool.
Yes, it's hilarious as shit, bro. You gotta watch it.
What platform is it on?
Peacock.
Oh, Peacock? I don't know if I have Peacock.
Yeah.
Ba-da-ba-da-bum-bum-bum. Did you see they had free weekend for Battlefield 6 this weekend? I was gonna hit you
Yeah,
up, see if you wanted to play. But I was
One was
sleeping.
crazy.
What's crazy?
I could also just get it for free for a week,
Wow.
but
What, because of Game Pass or what?
nope. My local library gives out games.
What? Your library gives
And
out video games?
Yes, bro.
That's sick. Is that how
Yeah,
they're
bro,
tempting
it's
kids to go to
broken.
libraries now? They're saying we have video game rentals?
They got me, bro. They got me.
Holy shit. Dude, that's
I'm invested
genius.
into the system.
That's genius. Get kids to
Yeah,
go to the
bro.
library. Tell them there's... So, because libraries always have, for instance, magazines for free, but you guys don't read shit.
They actually had a comic there too. It was Miss Marvel though.
Yeah, they probably have comics too. Yeah. Damn. That's impressive. DM's like, we do read. Okay. Well, you guys read, but I lies. I read all the time. Y'all are not the average. Y'all are watching a stream on education. Like, yeah, I should say the other part of the generation that isn't watching things like this doesn't read. Libraries have so much stuff now. Yeah. In Los Angeles, unfortunately, the libraries become like homeless shelters. Yeah. You've read over 2.5 thousand chapters. That's a lot of chapters, dude. Okay. Let me wrap up this question. Sorry. Using energy level diagrams, explain how a solar panel generates electricity and how it relates to grounded excited states. I don't know. Does this kind of answer Gladiator? Like what it is? I mean, you have photons that come in, electrons go up into higher energy states. I guess we could come up with a diagram for that, right? Energy states diagram. Maybe something like this. Your gym has treadmills with Disney Plus. Oh, that's sick. Disney Plus is useful for Star Wars. That's about it. Yeah. I wish I was a photon. I wish some light would just like smash into things. You could make Zach suffer, but he doesn't like the physics. Yeah, this is similar to light and the infinite well. Yeah. It is very similar. I want to know if I have like, wait, energy states diagram, solar, chemistry, maybe chemistry. If you just type in enough keywords, it'll come up with the right thing that we want. Maybe this. This is ResearchGate. This is like actual research. We don't need to do this. Oh, that's cool. Three-sided model. There we go. Let's just take this. I think this is great. Here we go. Let's just do that. It's just photons knocking off electrons that gives electricity. Exactly. Yes. And so what happens is when they're knocked off, okay, they go to this other semiconductor. So they're knocked off of the N-type semiconductor. They cross over the p-n junction, and then they enter the p-type semiconductor. And in doing so, these positive charges want to then return back home. And it's not actually positive charges. It's really what it is electrons are technically moving this way, but we describe current flow as being from positive to negative. Yeah. It's more fun when it's confusing. It definitely is. Yeah. I love being confused. But this is kind of maybe if you want the energy diagram for things, you can just say that light's coming in this way. This is like photon, light. And it doesn't really relax. I think it's knocked up and then it's kind of free from the orbits. And it transfers then over to the other semiconductor. And then in doing so, I know what happens, right? When the electrons return back to the n-typed, when the positive charges return. Yes. That technically, they're then just reabsorbing. Yeah, when this happens, this is how you get current. Okay, cool. All right, I think that's good. Let's call it. I'll take it.
Good job.
Well done! Well done!
Knowledge and character, yes, all great things. We love all these things. Okay, cool. Let me send the screenshot for you. All right, you mentioned LA reminded me of how much I want to move to the Bay when I graduate. Low-key not happening. Yeah, the Bay Area is really expensive. But if you have a nice job there, you're okay. But yeah, you need like at least 6 figures, a tech job, to live in San Francisco. At least in the nice parts of San Francisco. LA is also expensive, but not as expensive as San Francisco. And also, you get way more sunlight, so it's more worth it. I don't understand the people that live in San Francisco. I mean, the weather just sucks. It's just cold and like gloomy. I don't know. I really like LA. I'm a big fan of LA. Yeah, low-key pushing $500,000 to be comfortable. No, I think like 150. If you're making 150,000 and above, you're probably okay. You don't need $500,000. That's a lot of money. It is a lot though. San Francisco is definitely way more expensive than Los Angeles. Yeah, it's because of all the tech bros that live up there. LA has a bunch of like broke like actors. And like the Hollywood industry is not nearly as lucrative as say like Nvidia and Meta and Google, all those companies. Plus also like tech pros don't know what to spend their money on, so they just spend it on really expensive real estate, I guess. Yeah, I think San Diego is technically the most expensive city in the US when you adjust for income. So, for instance, New York is very expensive to live in, but they also pay really high salaries because it's usually people in finance or business or whatever. San Diego is also pretty expensive, but it's not as lucrative of a job market. You don't have, for instance, big tech like you do in San Francisco. You don't have big finance like you have in New York. And you don't have the entertainment industry like you have in LA. I actually don't know what you have in San Diego. You got the zoo, I guess, but that doesn't pay very much money. What's up, mini management? LA has more fent heads? No, I think San Francisco has more fent heads than LA. I haven't seen that many in LA. Okay, let's spin for the next winner for the next question we're gonna do. Let's see what we get.
Let's go gambling!
University of Waterloo's baiting me with their emails. Hey, it's DM Schrader! Congrats, dude. Your question's next. Yeah, best balance, probably, I don't know, like Arizona. Texas used to be decent. Austin, I think, was actually pretty decent. It's easy, but I'm lazy. Okay, that's fine. You know, so I had to interview a bunch of candidates today for the company that pays my bills right now. And one of the guys was a big data person. And we were talking about uncertainty and, you know, when the math says one thing, but it's technically misleading. And he brought up the quote that math is lazy. Yeah, he told me math is lazy. I was like, what? What do you mean math is lazy? I was like, dude, that's a bold play during an interview to tell me that math is lazy. Especially like, you know. But he explained it to me, and it kind of does make sense. especially in like statistics and probability, math is always trying to optimize for doing the least amount of work. I get it. It's if you're trying to do like a correlation, like for instance, like a least squares regression, right? You're trying to find something that has like the least amount of error. So yeah, math does inherently try to pick out like optimized situations. So I understand that math can be quote unquote lazy in that sense. And the analogy he was making is, for instance, his previous job was in finance. And so if, for instance, he was doing a lot with credit card transactions. So if you look at the math of like what percentage of credit card transactions are fraud, it's quite low, right? I think only about, he was telling me about 1% of all credit card transactions are fraud. So you might say to yourself, oh, we're crushing it, right? There's only a 1% chance that a transaction is fraud. And that's what math would say. Math would say, like, you're doing a great job. The unfortunate thing is that most of the transactions that are not fraud, right, the 99%, are small transactions, right? It's $5 here, $10 here, I don't know, maybe $30 if you're taking someone out to dinner. It's actually more like $200 these days. But most of the fraud is in the thousands. When someone commits credit card fraud, they're not doing credit card fraud on like a $5 transaction. They're doing it on like a $10,000 transaction, right? Or, you know, at least getting a couple iPhones out of it. So this was like an example of where like math is being lazy and telling you that you're doing a great job, you're crushing it, great job with the credit card fraud. But it's not weighted correctly to account for the fact that if you get a credit card transaction wrong and it is fraud, it costs you a lot of money. Yeah, that was pretty cool. So I was like, okay, bro, I see you. All right, anyways, so yeah, speaking about statistics and like probability stuff. Yeah, all the homies hate stats, yeah. There's apparently another quote, like there's small lies, there's big lies, and then there's statistics. Statistics is like the biggest lie. Oh, stream was so good you had to cook more bacon. Awesome, Devin. I'm glad the stream is bacon worthy these days. All right. Histogram represents the distribution of lengths in inches of 25 catfish. Catfish. Those are ugly fish, catfish. They taste good, though. Y'all making stats sound bad. Yes, exactly. Breasticles, I do think that the people are being lazy, yes, but I don't know. It was an interesting quote. You're doing optimization in your calc course. Nice. All right. So if possible, find the mean. If not, explain why not. Oh, well, you can definitely find the mean here. What? Yeah, this is totally possible. Why could you not find the mean? Maybe there aren't 25 things here. Yeah, I don't think you can exactly find the mean, right? Because this is binned, right? This is the issue. So, for instance, within this 3 to 6 bin, I don't know if all of these, like, if all of these 4 things are catfish with a length of 3. I don't know if they're all with a length of 4. I don't know if they're all with a length of 5. Can't find the mean because I don't feel like doing it. Yeah. Could you give a range? You could give a range, I guess, right? You could assume that everything in this bin is the low, right? So everything here is 3, everything here is 6, everything here is 9, everything here is 12, and everything here is 15. That would be the low end of the mean. And then the high end would be everything here is 6, everything here is 9, everything's 12, everything's 15, everything's 18. This is fun, actually. This is very similar to like a left-handed and a right-handed Riemann sum, if anyone remembers from like calculus. That's kind of what you're doing, right? You're estimating the area under this whatever curve. You can do it like either left-handed or right-handed. Yeah. So I would say yes, not possible. Unfortunately, I remember Riemann sums. They can never leave you. Okay, we're gonna say like not possible. Oh yes, I remember calculus. Okay, not possible. And then explain why. Because we don't know if, let's say, the 3 to 6 bin is 4 fish of length 3 or length 6, or a mix in between. Exactly. Well, you need to know the exact values of the fish. Now, find the median. You also can't find the median, right? Because I don't know what's in between. Yeah, also can't. I want to learn integrals of the summer because grade 12 doesn't cover it. What do you think is the best resources? Integrals. Oh, nice. I mean, I have a textbook I can send you, which I really, really like. I think it's a great resource. You guys said you like to read, right? If you like to read, I have a really good calculus textbook you could read. You can almost find the median. Yeah. Well, let's see. Proof of 1 + 1 = 2 when? Once I get Terrence Howard on my stream, dude. Inside Interesting Integrals. Oh, that's a cool book. Okay, one second. Let's look that one up. Resticles told us about this. What's it? Inside Interesting Integrals. Okay. Right. So apparently this is a cool book. Is this really middle school type integrals? I don't know if this is middle school. I mean, this whenever I see this style of book, I know this is by Springer. This always like brings terror to me. I know this is about to be tough. Yeah, it's not middle school. I love how they have a diagram of like how big the book is with a person. Okay. But yeah, Jeff is right. You could kind of find what the median is, because let's remember, when you're trying to find the median of a data set, you move from the left and from the right until you hit the middle. So for instance, I know that this would take out 4 of them, right? So I would have to go 1 here and then 3 here. So that would get me 4. Then maybe, do I want to go to another full 9? Oh, I don't think I can. Yeah, no. Okay. So then we could cross another 3 here, right? Which means we'd have to cross another 3 here. Okay. And then what do I want to do? Let's see. I can go up to 6. Yeah, okay. So then what I would do is I would cross another 5 up to here. And then from here I would cross 5. Or like this, yeah. Okay, so that tells me the median has to be this one. So the median is between 6 and 9 inches. Oh, it's 25 catfish, so the 12.5th catfish sorted. That works too. All right, nice to see you, Endeavor. I'm glad you made extra bacon for us. 6 to 9 inches long.
Huh?
No, God!
Yeah, okay. We do know it's in between 6 and 9. There you go.
Nice.
Yeah, okay. The catfish is between 6 and 9 inches long. Okay, were any of the fish caught 12 inches long? Again, you don't fucking know. I don't know. But because here's the issue, right? Right? So this is from like 12 to 15. They could have all been 13. Or this, they could have all been... Wait. Yeah. So this is the same, like, I don't know, like, where's that? 3 worst variable letters, E, D, and T. What is that? EDT? What? EDT. I learned what E and M means the other night. Does anybody else know what E and M means? It's a very LA thing. Praying someone comes in with real analysis. You are always useful, Norowski. I want this emoji. Okay, because this is what I'm going to do. There you go. This is the response I would put for your teacher for this one. Okay, so you still don't know this. Okay, were any of the fish caught 19 inches long? The answer to that is no. No. Because there's nothing above 19. Okay, cool. All right, I think it's good. Interesting question. It's kind of a useless worksheet. Like, what? What is your teacher doing? But anyways, it was at least fun to go through it. I'll give you that. This was DM screen. Oh, that's just one page of the homework. Okay. I think this is like early high school, right? Blue, are you in early high school or middle school? Okay, let's see what we got next. Yeah, early high school. Early high school. Okay. All right, spin, spin, spin. Who's gonna win?
Let's go gambling!
It's breasticles. Yes, come speak, breasticles. What do we have? Oh, Jesus
Hello.
Christ.
So I didn't type the entire question because I was too lazy to send
You're
it in
okay.
latex.
You're okay. You can send it later. Or what page is this on?
This isn't in that textbook. This is in a different textbook because I wasn't able to find a PDF for it, so I had to buy the actual paper one. But the question is to figure out the
Convergence?
Poisson summation, the Poisson summation of that.
Okay.
Sum.
All right, let's see. I'm going to have to like look some stuff up because I don't know what Poisson summation is. Yeah. Crazy Run says, I don't have an integral for you. Thank you, Crazy Run. Find the Poisson. What was it? Sorry, Poisson summation?
Yes.
Okay. Big Sport says, where is it? Sorry, what'd you say?
It's an identity just relating the time function and its Fourier transform.
Okay.
And summations. So
I think I see something here. All right. I'm glad, Big C Sports, that you barely passed calculus. I'm glad you passed. Passing is important. Maybe the next class though. Don't get a C in.
Huh?
And T for plus signs. E because of Euler's, D because of DDX, and T for plus signs. What's wrong? What are you trying about plus signs? Is this right?
It looks like it.
This is the Poisson summation, right?
Yeah, the simpler way to write it is it's just a sum from k equals negative infinity to infinity of f of k is equal to the sum of n equals negative infinity to infinity of big F being the Fourier transform of the function of 2 pi n.
Okay. I got this. This looks like pretty legit, right?
Yeah, that looks...
Right?
Yeah, that looks correct.
Interesting. Okay, and then x prime is whatever, just some variable, I guess. I see. This is a function of alpha or k, do we think? Probably of k, right? Or wait, no. Wait. Fuck. One sec. Function of x and n. When x equals 0. K is the index. It's a function of alpha. Okay, I agree with that. Okay, fine. Okay. So it's equal to the sum from k equals negative infinity to infinity. Negative It's a summation of an integral, dude. Wow, this is nuts.
Kind of. So you would actually start deriving it by taking the Fourier transform of your time function, which would just be the e to the negative alpha t.
Alpha t squared or just alpha t?
Alpha t squared. Yeah, sorry, alpha t squared.
Mm-hmm.
Because technically,
is this the Fourier transform? Is what this is basically, right?
Yeah. So you would want to find what that summation is equal to. So you would go about it by starting with figuring out your Fourier transform of your Gaussian poles, which is f of t equals e to the negative alpha t. So you just do the Fourier transform of that.
Okay, find the Fourier transform of e to the negative alpha t squared. Okay, which does alpha have to be less than 0? All right, then I gotta remember what like a Fourier transform is.
So your function from negative infinity to infinity,
and it's e I omega t
yeah.
dt. Yeah.
Mm-hmm.
Interesting. They put this 2 pi on this though. That's kind of cool. They do e to the because omega is 2 pi k. I see. Yeah, this is the difference between k space and. Yes, gotcha. Okay. Maybe I want to do it in this space. I don't know. I like the k's. So let's do negative infinity to infinity, and then that's e to the negative alpha t squared.
Mm-hmm.
Okay.
And then multiply by e to the negative omega t.
Oh, okay. E to the negative omega t. And then this is dt.
Mm-hmm.
We're doing the inverse Fourier transform. I think is what we're doing. No. This is a regular Fourier transform. My bad. Okay, sorry. Yeah. Okay. All right. Broken kidneys question's cool too. Nice.
You could just go through Feynman's technique to evaluate this one.
One of these days, I'm gonna remember Feynman's technique. I remember we just come up with something that looks like it. We take a derivative of it.
You can just differentiate it right now. Right now, it makes it, so you can integrate it. So
okay, so let's just say this is equal to g, right? We just say it's like equal to g.
Yeah, or it's technically it's big F. That's your
it's big F of k, right?
Omega.
Big F of omega. Oh, okay, because if it was k, we would have had the 2 pi k. Yeah, okay, right. So then I would say like df d omega, right? Is equal to this. And then this would be d omega, or partial now, of e to the negative, I don't know, I'm going to say like alpha t squared plus omega t, right? dt. Which is going to equal negative infinity to infinity, and that's going to pull down a negative omega, right? And then that's going to be
it should just
negative t, sorry, negative
pull
t.
down a negative t, yeah.
Negative t. E the negative, and then this is alpha t squared plus omega t. Okay, dt. And then this is integration by parts?
Yeah, you can just do parts.
Okay. So I think I'm just going to say that, so let's leave the negative out front. Hopefully I don't have to chase down the minus sign again. I'll say u is equal to t. Or wait, no. Do I want to do that? Let me think. Which one do I want to pick as t? As u, and which one is v? Huh.
I would break it apart, and then I'd say dv is equal to t e to the negative alpha t, and then I would make u your e to the negative omega t. That way the t e to the negative alpha t
I see.
squared.
You want to keep
u
these.
substitution.
I see. You want to separate
solve
these
that.
actually. Okay, I see. So you want e to the negative alpha t squared, right? Like this, and then times e to the negative omega t dt, right? Because
Yeah.
this is an integral I know how to do, because then I can do u sub.
hmm
You need a negative 2 alpha t plus omega to have the difference. Okay, below, yeah, okay. So yeah, so I'm gonna call. Oh, this is like going to the gym for calculus. Okay, I'm gonna call this dv is equal to t e to the negative alpha t squared dt. I'm gonna say that u is equal to e to the negative omega t. So then du is equal to negative omega e to the negative omega t dt. And then this is a u sub. So I believe... Oh, I gotta do this in my head. Let me think. I need a 2t. So I think it's gonna be 1/2. Yeah. Because I want to like put a 2 over 2 basically, and then that's gonna pull out. Okay, so I think it's negative 1/2. Negative 1/2.
And then yeah,
Negative 1 over 2 alpha.
Alpha.
Right, like that.
Yeah, that sounds pretty correct.
And then it's negative e to the negative alpha t squared. Yeah,
I think so. Yeah.
I think that's right. You can always check, right? By just like, oh, what would happen if we took the derivative of this? I would get a 2t alpha, a negative 2t alpha coming down, and so 2 alpha negative t. Yeah. Okay. Cool. Great.
Yeah, that's correct. That's what they have in
Good.
the book.
Okay. Yeah.
It's like,
Just work backwards. Okay. So then, did you graduate with a math minor? I graduated with a PhD in physics, which is basically a math minor.
also, I think we dropped the I in the second term of the.
You are totally right. We did. I didn't even fucking put it, dude. What?
Oh,
Don't tell Zach. I'm taking out his favorite symbol, the I. Okay. Yes. Do we want to keep the I in this one? Yeah, right? I guess it doesn't really matter.
Yeah, I would say that.
Just it's either that or divide by I. Okay. Okay, so then this becomes UV. And then there's another minus sign in front of everything, so that's positive. So I'm gonna get e to the negative I omega t, e to the negative alpha t squared over 2 alpha. And that's evaluated from negative infinity to infinity. Is this live now? It is. It is, Mr. Aronst. That's a cool name. Is it French? Okay. Minus, which then there's a minus here, so it's a plus. And then 2 minuses makes it a plus. Dude, all these minus signs. Okay. And then it's v to u. So that's going to be I omega over 2 alpha. E the negative yeah, that's right. There should still be an I here. I never studied this. Not many people have, honestly. This is kind of like a self-study book that Breasticles is working through to learn like some cool integration techniques for physics. And I guess he's doing engineering technically. But okay, and then this is DT. Okay, dokie. All right. I guess what we say is that this looks like the same shit as this, yeah?
Mm-hmm.
Okay.
So from there we can
Oh, God.
turn it into a differential equation.
Yeah, all right. So let's well, first of all, I need to like move this over, right? Sorry, I'm going to take all this. Oh, wait. Sorry, I can just say this is DFDW. No, right?
That would be F omega.
Yes. Oh, you are right, actually. Oh, yeah. Oh, that's sick. Yes. Okay, right. Yeah, and this whole thing here is DFD omega. Yeah, this is DFD omega. Cool. But then this thing right here looks very similar to what our original expression... Okay, I'm starting to understand this Feynman thing. That's this shit. But also with a I omega over 2 alpha. Right?
Yeah.
Okay, cool. Okay, so now... Alright, so let's make things a little bit smaller. So I have df d omega is equal to e to the negative, and then we're going to say I omega t plus alpha t squared over 2 alpha plus...
Well, we can just remove that term entirely. Because once
just because it's symmetric?
Well, if we evaluate it at the
bounds?
negative infinity and infinity...
right, this will blow the fuck up, yeah?
To 0, yeah.
Yeah, exactly.
Yeah,
okay,
it'll go
yeah, I agree.
Straight to 0.
This goes away. This goes away. This dies at plus or minus infinity because you have t squared. And then there's a minus out here, so that's always going to sink the ship. Yeah. How do you do limits with I? Oh, interesting. I think we only consider the real part. Maybe. Well, at least this is a real part times an imaginary part. The imaginary part is always just oscillating, yeah? And then, but the real part's going to 0.
Yeah, you could also imagine, right, our original function is f of t to the negative alpha t. There's no imaginary part of that. What we're doing is we're using a Fourier transform to convert something that was in the time domain into the frequency domain.
Right.
So
and then the
kind of
frequency
just off of inspection,
it has to be real.
as that goes to infinity, it still dies out.
Yeah. Okay, and this is plus I omega over 2 alpha. And then this is just f, right? F omega. F of omega.
Mm-hmm. I guess technically too, I is a constant. It doesn't affect your limit when you bring the limit up into the exponential. You can just move the I up front and evaluate the limits.
For this one, you mean, yeah?
Yeah, but you would, since it's just in terms of e, you would just bring the limit up into the exponential.
Yes.
Break it into the 2 parts of the addition.
Yeah.
And then just move the I out front of the
other one. It's still plus or minus
yeah.
infinity. Yeah.
Mm-hmm.
Yeah. Okay. So, all right. So now I have df d omega is equal to I omega over 2 alpha f, and this is a well-known solution.
Yeah, except somewhere in there they have a negative.
Dude, I fucked up. Another minus sign?
Yeah, somewhere there's it's a negative I times negative I, so it becomes negative alpha or negative omega over 2 alpha.
Oh, really? Okay, let's go hunt for it. Miss Arden says, do you think 27 is old to start with a math study, starting with a bachelor, master, hopefully PhD? No.
Surprise, motherfucker.
No, 27's fine, dude. I say, like, if you're reading this, it's not too late. I do agree, maybe if you were in your 40s and 50s, you would maybe just not have the stamina and energy to do all this. Like, I even look at myself. I'm 36 now. And I consider all the all-nighters I had to pull in my 20s to get through some stuff. And I'm like, I don't think I could do it. It's just a lot of sacrifice. But if you have the financial freedom and, like, the family freedom and, like, you know, you don't have to take care of other people, yes, totally can. You can for sure get the bachelor and masters, even if you had, like, a family. The PhD might be a little difficult. 'Cause the PhD takes a lot out of you. Okay, where the fuck was this I we lost? Oh, man. Okay. Let me see. This was cool. I did this derivative.
I think it was when we did parts. I
Oh,
think it was
you know what?
because we forgot the I.
Yes. Yes, because I forgot the I here. This should have pulled down
And yeah, an IT.
IT. Yes, yes, that's where it came from. Yep. What's up, Zach? A Fourier transform, he says. It is. It is a Fourier. It's your favorite. Okay, so whatever. Let's let's put the I there, right? Let's put the I here.
Yeah, and then I think everything else is correct. And once we
Yes, okay, because then we get I
over the
times
negative.
I, right? Integral v du. So this is going to become -1, right?
Yeah.
So then this is minus this. Beautiful. Okay. What's up, Zach? Shout out to Zach. Let me give him a shout out. Awesome guy. Zach's been on, you're on your spring break, right, Zach? Coming back on Wednesday, I think? We have a meeting Wednesday morning, right? We're going to talk. I want to do, the 16 trivia. In a manner of speak. Yeah, I know. It's never actually a break.
You done messed up, Aaron!
It's never actually, there's no breaks. We cut all the breaks a long time ago. Okay, cool. So I think we're to here. Yeah, you had a lot of work to. Yeah, you installed Arch Linux. Yeah, that's tough, bro. Okay, so the solution to this, I think, is just e to the a. It's e to the at, e to the a omega something, right? Yeah.
Yeah, they say f omega equals c e to the negative omega squared over 4 alpha.
Okay. If we wanted to like solve this, I think we would say, you assume, right, that it's of the form like c e to the. We're using all the terms already. Let me think. Let me say like x omega, right? So then f prime omega would be equal to cx e to the x omega. Yeah.
Yeah, you could do that, or it is just a separable differential equation, so you could just bring the.
Oh, it is separable. Oh, you're
f
so
over
right.
to the other side, the d omega to the other side.
Yeah. Yep.
Integrate, and
Let's do it. Let's do it. Let's do that. I like that. I like that way much better. Yeah. I forgot that these things can come apart.
Surprise, motherfucker.
You can split them. They don't have to stay with each other. Okay, so let's move this over. So we get df over f is equal to negative omega over 2 alpha d omega chi omega. So that's a frat. Alpha chi o. I remember those. Okay, right. And so now I can integrate. Yep. This becomes that the ln of f is equal to, is that negative omega squared over 4 alpha? Did I do that right?
Yeah, that's correct.
Right.
Yeah.
Okay.
And then
e, and then this is technically like plus c. So then we do e to the. What's up, Mohit? How's it going, dude? So this gives us f is equal to, and then like this just comes out as a multiplicative constant, c e to the negative omega squared over 4 alpha. Okay. Awesome. So after doing all of this, you had something close to this as homework, really, V Sigma? Or this is something else you did. One second, let me see what you had. Is this what, classical analysis? Sorry, one second. Oh, this is in interesting language. I don't know what this is. Okay, let me see. What? Narosky, if you want to take a look at that, you're my resident math genius. It is Romanian. Oh, V Sigma, do you know Narosky, our other resident Romanian vampire? He's quite smart. Okay, I have f omega. I'm happy about that. What was the point of finding f omega, by the way?
So what it because basically what the we want to figure out an equivalent expression to that summation. And the Poisson summation says that the sum from is negative infinity to infinity of f of k, where k is the index, is equal to the sum from n equals negative infinity to infinity of the Fourier transform evaluated at 2 pi n.
Oh, okay. So this is f of 2 pi n.
Yeah, so you can basically put that original summation of the Gaussian pulse in terms of its Fourier transform and its period. And so you take the Fourier transform, you just have to evaluate f of c, and then from there you can just plug into the summations.
Okay, because f of omega was equal to all of this hot garbage. Hot garbage. C stands for combination here. Yeah. Oh man, why did it not copy correctly? What? Excuse me. One sec. Okay. There we go. Oh, it wasn't copying for me. Okay. One sec. Ardalon says, I'm studying maths every day. At the moment, pre-calc. I'm a late bloomer. All good. I always say, like, no two paths take the same amount of time. Nor do they have to go straight. As long as they go forward. But I want to become an astronomer so bad. I've been putting the work in, but have a long way to go. Well, keep at it, dude. You're at least trying towards something. That's better than what, like, 90% of the population does. So... if you need help, Mr. Ardance, or Aronst, you're gonna have to tell me how to pronounce your name. Please feel free to like join our Discord. We have a cool community of everyone from middle school, high school, up to like adult learners. Where's the website? Yeah, here. Actualofficehours.com. You click here, join our Discord. You can say hi to me, and we also have some cool free courses, like some like boot camps, just to make sure you have like the math fundamentals. Stuff like fractions, exponents, a little bit of trig. And also this stream, if you ever have a question on anything that you're like self-learning and you want to submit a screenshot here to the stream, we'll do it here on the stream. This is a very advanced question. I don't want this to scare people. Like, this scares me. This scares me. Like, don't worry. Like, we also do very chill shit as well. Like, we also do like I guess this was pretty chill. McLaurin series, yeah. This is very chill. Yeah, look how nice this is. Yeah, we also do this stuff. Breasticles just brings really fun things for me to learn, like munch on. Okay.
Yeah, dude.
Yeah, I'm munching hard. Let me see. Okay, so this thing I think is the same as this, but instead of saying 2 pi I k x, right? We're gonna do this in terms of omega. So this is e to the negative omega t dt, right? And then this is f of t.
Kind of. I'd say the easiest method, at least for this specific example, is to just say that it's equal to that summation, and it's just your Fourier transform. Of
which summation? Which summation is it?
So you're right. Your left-hand side is correct.
We have a lot of summations.
So I just put your left-hand side in terms of k for the index.
This one?
Yeah. So that's our f of that, right? So it should be the summation from k equals negative infinity.
Got you.
To infinity of f of k.
Got it. Okay. Yes. F of k is equal to all that. Yeah.
Well, instead of writing all that, you can just say the summation from n equals negative infinity to infinity, and then big F for the Fourier transform of 2
Of
pi.
omega. Interesting. The 2 pi n, where does that come from? Sorry.
That comes from your period. There's a derivation in the book. I can send you it if you want. It's only like 2 pages showing how they get to it.
Because
but
I
that
see
just comes
this. I
from
mean,
that.
this looks kind of like this, right? That's my f of k, right? And then I see my e to the negative I omega t dt. That's what this is. Unless
So that formula doesn't directly come from this question. This question is an application of that thing.
got you. Okay.
So there was a different derivation that Poisson did, using some summation properties and integrals with the period of the Fourier transform to get to that specific identity.
Okay. So we're going to say this is f of 2 pi n, right?
Yeah. Mhm.
Okay. And I know that's equal to this. So I got to evaluate for c.
So, and you would just say c is equal to f of 0 in this case, which would be your Gaussian integral. So you can just bring in your solution to the Gaussian integral, which is root pi over alpha.
Root pi over alpha. Okay, one sec. Okay. F of 2 pi n. Move, please. Thank you. You go up here. This is f of omega. So f of 2 pi n means this is going to be e to the negative 4 pi squared n squared over 4 alpha. Yeah?
Yes, that looks correct.
Okay. And then f of 0 is just, well, that is c, I guess, right? Yeah, because when this is 0, you get just c. Okay, but then if I want to evaluate f of 0, I had to go here, I guess, right? And that would just be this, right?
Yeah.
Okay.
And that's just your Gaussian integral.
That's a Gaussian integral. Okay. Here, one second. Let me pull that down. Got it. What's up, coolest dude? Mr. Aron says, thanks so much. I've been seeing your shorts and first time I'm joining the live. Well, welcome, dude. Welcome to the live. I would be grateful to join your Discord. Yeah, please do. Tell me if the link works. I hope the link works. Dude, if this copy paste doesn't work again, dude, I'm gonna lose my mind. Technical issues. Oh, what? You just want to paste over there now? What? Stop. Dude, what? This the whiteboard doesn't like your question here. It's just like, no.
Apparently not.
Surprise, motherfucker.
I don't blame it.
Yeah, I get it. Okay, all right, here we go. F of 0 means this goes to just 1. And so that's equal to integral from negative infinity to infinity of e to the negative alpha t squared dt. This is a Gaussian. Which, what does that come out to? I could look it up, I guess.
That's it's root pi over alpha.
Root pi over alpha.
All of it's square rooted.
Oh.
Yeah.
Okay, cool. Okay, cool. So then all of this is now equal to the summation from n equals negative infinity to infinity of root pi over alpha. And then it's this. Okay.
And then you bring the root pi over alpha out from the summation, right? Because it's just a constant.
Yeah.
And then so now we know that summation is equivalent to our original summation that we were trying to find.
And so this is it? We're done?
Yeah.
Oh, beautiful, dude. Nice. I don't know what the point of this was, but it's cool.
Yes, it pops up in like, I guess, the Jacobi theta function in special cases. He goes through it as an example, and then he's like, I'm not going to really go any further into how this is important, but it is basically what he said.
I've been there before. This is kind of like the eat your vegetables of math. Like, eat your fucking broccoli. Yeah. Like, why? Why do I have to eat my broccoli? Okay, so we basically show that this thing turns into this thing. Oh.
Yeah. Which I guess is nice because now it's in terms of, right, I guess, in terms of the period and frequency rather than in terms of your time.
Okay. Cool. Taco Cat says, Gold, can we do a wheel spin for bond coins for me? I'll put up like 10 coins for my channel points. No, you guys can't gamble more. A wheel spin for bond coins. Well, we just love gambling. Oh yes, man, we're big fans of gambling. I know it's a biologically favorable I don't know, like mechanism for dopamine, and so that's why we incorporated it here in the actual education live stream for answering math questions. Also, like, I think it teaches probability, so like, it's kind of math related.
Good job.
Yeah, I agree. I think it's good.
Yeah. I did see something. Apparently, there was a bill passed. They're no longer going to allow Kalshi and Polymarket to bet on sports events because I think that's like cutting into like FanDuel and like all their money. Also, I just think it's weird people betting on like real world events, especially if all the insider trading is nuts.
I had a friend who took out his entire savings and then betted on the election.
No.
Bruh.
Did he win?
Well, he won. Yeah, he won.
Okay.
And then
Good for him.
he came back. He was like super hyped. He's like, yeah, I put in my entire savings on the election. I'm like stacked now. And
It's like I won, but at what cost?
Oh.
I won, but at what cost?
Yeah, he was very confident in that election. I wouldn't have risked my money on that.
I mean, I would have been too, honestly. Like, yeah. This is the meme I think about. Like, I've won, but at what cost? There was another cool, interesting thing. Man, what was it? It was a sentiment on gambling study. There was... Man, where am I looking for the graph? There's a great graph on this. It's like ethically okay. Yeah, maybe it was this. Oh, one sec, I got it. TikTok's mad at me. Okay, there you go. You're fine, TikTok. Is gambling immoral? Yeah, there was another thing about like different types of betting. Sentiment on types of betting. Like, apparently, like, slots was seen as, like, favorable. Like, slots is, like, investing. Slots, investing. If I type enough things... Here we go. This is it. Oh, my God, I found it. If I type enough keywords, it'll come up. Okay. How Americans view prediction markets. More like gambling than investing. Okay. Percentage of respondents who said various financial activities are more like gambling, investing, or a mix of both. Not a rest. Okay, so apparently still there are some people, there are a non-zero percentage of people that believe using a slot machine is closer to investing than gambling. What?
That's interesting.
That's scary, dude. What? Who thinks slot machines are investing? I wouldn't call gambling immoral. It's more like smoking. It's just a bad life decision. Yeah, I mean, until, like, it puts a strain on the healthcare system. That's the only problem. I mean, that's like saying, like, obesity is not immoral. It does technically hurt other people eventually. Those are Cheds. I guess the casino is just giving away money. It's all free.
Oh, yeah.
But, yeah, interesting. Crypto is kind of a mix of both. But, yeah, wagers placed on sport books, event... It's interesting that they think the event contracts on prediction markets are less gambling than sports books. Kind of all the same to me. I don't know. And then, of course, buying stocks. Yeah, I mean, I could say stocks are investing. My dad always said the stock market was gambling. No. That's why I don't really play stocks at all. I think you should have like a 401k maybe. But in terms of some of my friends are super degens with like derivatives, you know, options and stuff, and I'm like, no, y'all need to stop. Gambling is a tax on those who don't know math. One of my college professors. That's a fucking good one. I love that, Zach. That's a great one. Okay, wow. We have a really awesomely huge queue today. Holy shit, 12 questions. Okay, let's go see whose question we're gonna work on today. This is awesome.
It might be partly because we just spent like 30 minutes on the last
Did we?
one too.
It was okay. I learned something.
Yeah, I think
earlier.
it was like 30 minutes.
Oh, let me give you a coin first of all. Did you accept my friend request on Steam?
Yeah, yes, I did.
Okay, cool. All right, just remind me in like 3 days. I'll send you the gift card.
I bet.
All right, let's go pick somebody. Who are we gonna pick?
Let's go gambling!
I've never seen the wheel so colorful. There's so many names on it now. It's probability. Answered 30 minutes ago. Again, if you submitted to the queue and you want to have a better chance of your question being answered, some people are already doing it. You can click this upvote button here on the right. It'll help you out. All right. Ooh, Poisson distributions. Zach, might be for you, man. Might be for you.
That's 2 Poissons in a row, actually.
Yeah, you technically had another one as well.
Yeah.
There are some really disgustingly difficult looking questions in the queue. All right. Well, I like things that are just disgustingly difficult, apparently. Fembox says fun. Jeff says no. Okay. Okay, let x be a geometric random variable with a parameter p equals 1/3 and y be a Poisson random variable with a parameter lambda equals 4. Assume x and y are independent. A rectangle is drawn with side lengths x and y plus 1. Find the expected values of the perimeter and the area of the triangle. Okay, cool. So this is like, or you're groaning at Zach's joke? Oh.
Disqualified.
Sounds fishy. But not easy. Yeah, I guess not. I think the perimeter is probably easy though, right? The perimeter one's probably easy. We can do perimeter pretty easily. Yeah. So, okay. Oh, Poisson is French for fish? I didn't know that. I just know Italian and Spanish. Okay. X, y plus 1. Yes.
Start calling it the fish equation in
Does the
E&M
fish-
then.
The fish equation. Dude, and you know what's hilarious? Our first question of the day, or second question of the day, was about catfish.
Exactly, it's ironic.
Dude, yeah, dude, like this is, dude, conspiracy confirmed. There's a fishy conspiracy on today's stream. Okay, so for perimeter is sum of the sides, which would just be x plus y plus 1, technically times 2. But here, I'll do it just for the kids. We'll put the full thing out. It's like that, right? It's this side plus this side plus this side plus this side, which is the same thing as 2x plus 2y plus 2. Okay. X is a geometric distribution. I need to look some stuff up. Fish to April? What's the fish of April? April fishes, what's that? Is that like some religious thing? Okay, and we want the expectation value. Is that the same thing as the mean? Fisher information? I have no clue what this stuff is. For some reason, summing and multiplying probability distributions isn't clean. Interesting. Okay. Well, okay. Adding geometric and Poisson distributions. I have no clue. I thought adding is easy. Multiplication, I understand, is weird. Okay, adding a geometric random variable and a Poisson random variable involves computing the convolution of their probability mass functions typically resulting in complex non-standard distributions used for modeling clustered rare events. The sum is usually calculated by using summing joint probabilities. Who submitted this question to me? Okay. Let's see. Basically, x plus y equals k. So one distribution is x, the other is y. I agree. But for all values of x and then integrate. Man. This is like some graduate level probability statistics stuff. So you can ask, how many ways can x plus y equals k, and then you give up.
Surprise, motherfucker.
These problems looking good? I don't know if they're looking good or if they're looking fucking tough. Yeah, also the algorithm always brings in, based on whatever I'm doing, it'll bring in an audience appropriate to what that question is. So if I'm doing chemistry,
Yeah, that's what I was thinking.
it'll bring in chemistry people, but we were doing Poisson distributions, breasticles, and so now it's bringing in all the fucking probability people.
I'm not even talking probability. Like some of them are
Super crazy.
some wild questions.
Yeah, so I agree with this fembox. I thought the expectation value of adding distributions you could do independently, right? Is that not true? Can't I just find out, like, this is just 2 times EX plus 2 times EY? Yes, I understand that the multiplication won't work. That's okay. Plus 2. But then I think the question here is, like, what is EX? Yeah, expectation is linear. I agree, fembox. That's what I thought. Why is Google's telling me I need a convolution? Or maybe that's adding the maybe that's okay, that's different. We're not combining the distribution and then finding the expectation value. We're finding the expectation value of each distribution and then adding those. Got you. Yeah. Okay. Got it. Yeah. Okay. All right. So then let me see what the expectation value. So expectation value of a Poisson distribution is. What's that? Apparently it's just equal to fucking lambda. Nice. Okay. Well, that's for Poisson. So sorry. So EY is just equal to lambda. And then, what's the expectation value of a geometric distribution? Is 1 over P. Okay. If modeling the number of failures before a first success, I think we're going to assume this is just P, just normal for success, right? Okay. So this is equal to 1 over P. Which is equal to 1 over 1/3, which is equal to 3. Cool. All right, so perimeter. That's going to be equal to 2 times 3 plus 2 times lambda plus 2. Nope, I don't know why I wrote 6. Okay. So this is just going to be equal to 2 lambda plus 8. I think. Yes, that is Jeff C. Groves. This is his new Twitch. I don't know why Jeff got a new Twitch. Jeff, if you want to elaborate. Okay, let's look at what area is. Area is going to be difficult.
Oh shit, not good.
Okay. Area, that's going to equal to x times y plus 1. Yeah, it's a party. Yeah, what's up, Joseph? Here, if I give Joseph another shout out, Joseph, we're gonna nudge Joseph to stream more. I'm gonna get you, Joseph, dude. Go give JC a follow so he knows he has to stream on Twitch. He's our CEO of chemistry. Okay, so this would be xy plus x. Uh-huh. And I believe, right, this one I can just calculate the expectation value of this, right? We already know the expectation value of x is just equal to 3. So I think this is the tough thing, right? The expectation value of xy. Did they give us lambda, sorry? Oh, lambda equals 4. You're so right. Yep, thank you. Okay, so it's equal to 8 plus 8. Okay, 16. I'm gonna go to sleep. It's 2:27 where I live. I'm glad I enjoyed. Yes!
Good job.
Thank you, Mr. Aronst, for coming by. We'll see you in the Discord. My name's Dr. Gold in the Discord, by the way, so feel free at me at any time if you have any questions or help or want to help. And then, also, when you joined, there's a nice, fun little calendar. Wow, this queue is getting big. If you click here on the streaming schedule, you can see all the different streams that we have. So we're the ones in gold. But also, we have awesome people like Math Pond. He's doing a math stream tomorrow. And then Zach's getting back at it with DiffyQ on Wednesday. And then Penn Center is going to also do like some math homework help Wednesday. And then they have a podcast on Thursday.
Good job.
It's a cool little thing where they discuss like a bunch of different random topics in math and teaching and education. Go check them out. I should give a shout out to Penn. Let me give a shout out to Penn. Penn Center, who just hit 1,000 followers.
Good job.
I have to wait 71 seconds before I can shout him out. Okay, whatever. We'll wait. All right. I gotta remember that calendar. Yeah. Don't forget the calendar. Also, if you know other streamers who are looking to, again, join our community of awesome other math science people and just want free exposure, please, like, send them to me. I would love to add them to the calendar. Will we have to call him Dr. Zach or Dr. Penn Center? Well, Zach is E to the 2I pi, and then Penn Center is Penn. I don't think they're as pretentious as I am to put doctor in front of their name. Okay, how do we find the expectation value of xy? Let's do that. Okay, expectation value of geometric and Poisson. Yeah, you're more than welcome. Yeah, great. Get some sleep. Thanks for staying up late to see us. Is it just EX times EY? See, how do you guys know that? Oh, I guess because the length, right? Well, oh, because X and Y are independent. Yes, beautiful. Right. Okay, I like that, yes. I feel dirty using these shortcuts, but I believe they're true. Work smarter, not harder. Okay, good. Right, because the covariance of X and Y is equal to 0. What that means is the result I get from Y doesn't affect the probability of what I get for X, and vice versa. I wanted to convolve. I wanted to reach your final form. Okay, so this is 3 times 4. So that's equal to 12. Cool. So area equals 12 plus 3. What's up, Lonesome? Which is equal to 15. And I think that's all we needed. Yeah, nice. Okay, great. Good job. I'm just curious if I throw this in the chat, what it'll say.
Well done.
Solve. Go solve. Zach, I hope you're still working on that project. Would like to contribute. Zach works on a lot of projects. We're gonna meet on Wednesday about his trivia game project. 16, really cool. Super fun, super fun thing. Okay, probability. Your question's going into our Discord. So again, if you're new here and you're wondering how all of this works, so every time we do a question that you guys have submitted on the stream, it'll get put into our Discord right here. So here, for instance, is probabilities question. There's also a fun little link to the YouTube video, and it's time-stamped. So you can also go back exactly to the time live replay what we did during the stream. And then there's also a screenshot here of the question. And if you're in our Discord, you can earn points for asking questions. So just react to the post if I don't know who you are already. And we'll make sure you get points. He had to touch grass. He did, yes. And he's going to a conference. I came across Math Fanatic the other day, and he was doing his animation. Yeah, he's dope. Math Fanatic, he sent me the code for his most recent thing. I'm gonna go check it out. Uh-oh, Breskel says there is an analysis question. Look at all these questions. This is probably the biggest I've seen our new gambling queue. Love it. Okay, let's go pick a winner.
Let's go gambling!
Broken kidney! They're definitely not all getting done tonight. Maybe not. We'll see. We'll try and get... The ones that I can't get done, don't worry. They always get put into our Discord as well. So your questions are not lost or forgotten. Just maybe temporarily not answered. Analysis. Oh, you guys were discussing this in the chat? Okay, cool. Well, I think you guys are going to have to teach me because I have no clue what this means. Okay. The result of the computation. This is a summation from k equals 0 to n. And I think this is 3k choose 3n. Is that what we say? My kids have been using Let's Go Gambling a lot. Kids at their school have been playing soundboards. That's how we stay relevant, Zach. I actually didn't think the Let's Go Gambling was that popular. I've seen it like in previous memes, but I thought it was very appropriate with the question queue lottery system we designed. So I wonder if like I'm restarting a movement. Oh, it means 3n choose 3k, by the way. Oh, okay. I didn't know. Okay. Seems kind of weird. It goes from bottom up. Oh, I guess for an integral, right? It's like bottom to top. Unironically, you started using it around the same time as my kids, and ironically, maybe your kids are like secretly watching my streams. I remember we've discussed before, like at what age you think it would be okay for your kids to watch Twitch. But I also like, again, I don't have children of my own, so I can't use that as a metric for like how I present myself on live streams. You do, which is cool. You can be like, I would always want to do something that my kids could see. I have like no clue what I would want my kids to see because they don't exist yet. Okay. So this is 3n choose 3k, right? I would write it like this. I like n choose r. This is my like preferred format that I know of anyways. This is true.
Huh? That's dope.
Are there mini Dr. Golds running around that I'm not aware of? Could be. Okay. Okay. K equals 0 to n, but it's in both of these as well. Wow. Maybe I want to start writing some terms out. You think that would help? You never used Twitch before? My streams? Wow. Okay. Nice. Welcome. Maybe I should ask the Dan from Twitch if I should get like a referral bonus. What's up, Alistair? Good to see you, dude. Been a while. Okay, let's come up with like what the equation for like n choose, or one sec. Were we right on this one? Yeah, 16. Wait, 16 and 15. Uh-oh. No. Wait, whoa. This last one I thought we got right. Sorry. Oh, 16 and 15. Okay, we're good. Sorry. I was scared for a second. All right, I'm gonna use chat because, well, no, I'm not gonna use chat. I know this. Choose function. Yeah. Okay. So n choose k written this way, right? Okay. This is why I thought it was top bottom, right? But y'all are telling me like in that other notation it's the other way. Okay, so You think the problem's just written wrong? Oh, okay. That could be true. Okay, so this is the sum from k equals 0 to n of 3n factorial, right? Over 3k factorial, and then it's 3n minus 3k. Correct, right? 3n minus 3k factorial. Oh, interesting, V sigma. Okay, cool. Thank you. Thank you for that. It's another little piece of useful information. Okay. You use the all-powerful triangle. I don't know what that means. Okay, Yes, Pascal's triangle. Sure. Well, let's see if k equals 0, right? I gotta remember, 0 factorial is just 1, right? So let's just do some cases. Yeah, if k equals 0, then I have... It's like you have 3n objects, and they're asking how many ways to choose 3, 6, 9, and 12 items. Okay. But you can only go up to... So eventually you're just going to go up to 1, right? Because eventually you get, like, 15, choose 15. Yeah, okay. So this would be 3n factorial over 1. And then, oh, just over 3n factorial. Okay, cool. So this is just equal to 1, right? When k equals 0? Okay, and then if k equals 1, then you get 3n factorial over 3 factorial, and then it's 3n minus 3 factorial. Okay, cool. Which, again, I can write this out a little bit differently, yeah? I could write this as 3n minus 1, 3n minus 2, 3n minus 3 factorial. Yep, okay, cool. And then that's all over 3 factorial, 3n minus 3 factorial. Okay, so these cancel. Okay, cool. So then that's, yeah. I actually see maybe a pattern here, right? Actually, no, I can't do that.
No.
Damn. I wanted to hit all of them. Okay, fine. So 3n minus 1, 3n minus 2, all over 3 factorial. Okay, cool. And then I see if k equals 2, I kind of see like a no slide and divide here. Breasticles did provide a proof for the slide and divide. I should share it later. It's funny. Although I don't want TikTok to ban me for the Zin. They would. They put restrictions on my account for like so much dumb stuff. Okay, so this would end up being, because this bottom term, if k equals 2, that ends up being 6 factorial, right? And then you get 3n minus 6. I see. So you would end up getting 3n minus 1, 3n minus 2, 3n minus 3, 3n minus 4, 3n minus 5. And then this would be over 6 factorial, right? That's the pattern. Like this goes from 3n to 3n minus, I don't know, like k minus 1 or 3k minus 1. Okay, and the goal here is to see like what does that turn into. It is quite ugly.
You done messed up, Aaron!
Yeah, she's not pretty. That's for sure. Seen better days, as they say. Okay. You posted a triangle picture? Thank you. Let me go see. Okay, this is Pascal's triangle. I see that. Maybe let's try to see. Yeah, what do all these fun little numbers mean? Are you drawing triangles within the triangles? Is this like a Triforce thing? Every third row, every third column. That's Sierpinski's triangle. Ooh, okay. But what does it mean? Is it all the ways to choose 3n things from 3k things? And then as n goes up to k? Yeah. Or no, as k goes up to n. I will not accept the slide divide hate. If k equals 1, use row 3. If k equals 2, use row 6. Wait, what was that? K equals 1, use row 3. So wait, this is row 1, right? So use this one. Okay. Because what? This would be 3 choose 3. This is 3 choose 1, right? There's 3 ways to choose 1. Is this 3 choose 2? Oh, 3 choose 0. Sorry, that's what I meant to say.
Yeah.
Yeah, okay. Got you. Yeah, I forgot it starts at 0. Yeah, okay. Got you. This is 3 choose 0. This is 3 choose 3. But you're counting by 3s. About to hit the sack. Here's one from the National Math Olympiad. Cool. Post it, Narowski. So 6 choose 0. What's up, Legendary? Okay. This is 6 choose 0 then? 6 choose 1, 6 choose 2, 6 choose 3. Which, this is n equals 2. This is n equals 1. And then it's a summation, though, right? Right. So you're summing all of this, and then you're summing all of this, and then you're... Okay, so what's the equation for the summation of Pascal's triangle on a row? This is definitely harder than it looks. I think you need to either bash it with an identity and then find a recurrence relation, or use a generating function. Oh, wow. I think what I would do is I would just take this and plug in a value then and see like which one works.
Oh, yeah.
Right? Yeah, test it with a few values. Yeah, exactly. Yeah. So, I'm a lazy mathematician. But it would bother me, yeah. Okay, well, we know okay, we know that if n equals 0, right, the answer needs to be 1. So let's see like which one of these don't work with that, right? So if n is equal to 0, I need 1. Well, that works. Right. This does not. This does not as well. These do. Okay, so now we're down to... Let me see. 2 plus 1. Yeah, that one works. Yeah, that one works. That one works. It would be pretty tough, yeah. Okay. All right, so then let's check this one, right? Let's check if n was equal to 1. If n was equal to 1, right? Then I should get 3 times 2 times 1. Oh, 3 factorial of a 3 factorial, right? I should also just get 1 if n equals 1. Oh, no. I should get 2 because I go from k equals 0 up to k equals 1. Okay. Okay, so n equals 1 should give us 1. N equals 2 should give us 2. Where does that happen? Doesn't happen here. No. I'll tell you that. That doesn't work. Doesn't equal here either. Let's see here. These are all really big though, no? This is gonna be 2 to the 6th. It's huge. All right, sorry, no, sorry. N equals 0. Sorry, I have this wrong, sorry. N equals 0 goes to 1. N equals 1 should go to 2. That's what I meant to say, sorry. Okay, much better, because I was like, well, yeah, that's about to get really big. Okay. Which, yeah, that one doesn't work. So, let's see, which one of these when n equals 1 do we get 2? This gives me 10 thirds. No. I don't think so. This gets me 8. 8 minus 2, which is 6. 6 over 3 is equal to 2. This is it. Okay, do we think the answer is B? Yeah, some of these answer choices don't give integers. So I guess wait, I don't want hat. Let's just see I want to see how like chat does it. Have you tried using Ramanujan's method, just being told in your sleep? Huh? My sleep is like reserved for like ex-girlfriends coming to like haunt me. I wish they would tell me some math tricks. That'd be great. Okay, let's see what they did here. Key ID is the roots of unity filter. To extract only terms where the index is divisible by 3, we use this. Someone submitted more Fresnel integrals.
Surprise, motherfucker.
Stop. Okay. Omega is that. Omega squared is that. Evaluate. Combine. You get answer choice B. It is roots of unity indeed. I don't know if I understand this. Yeah, what? Where does this come from, guys? I don't think I've ever seen this. This thing I've never seen. 1 plus 1 to the 3n, 1 plus omega to the 3n, 1 plus omega squared to the 3n. I don't want to understand this.
No. You done messed up, Aaron.
Okay, you know what? I will share the link to this in the posting on Discord too if you want to understand it. Just in the essence of time, because we have 15 submissions and 50 minutes left. I'm gonna move forward. Jesus loves me. Thank you. I need some more Jesus in my life, honestly. Okay, cool. All right, we got the right answer, so I'm happy. Good job. Broken kidney. I hope, Broken Kidney, you're not using these questions to try to pay for a new one. Maybe that's what we're doing. We're like secretly solving Broken Kidney's like impossible questions, and they're getting money towards a new kidney. That could be happening. I'm terrible at math, but I know Jesus plus your repentance equals salvation. I'm down. Where do I sign? Please. Okay. All right, so I posted the screenshot to that question right here, and I'm also going to post the ChatGPT link if you guys want to go through the submission for that one. Psalm, how about I help you out with math and you help me out with, I don't know, my divine balance credit report or something. Deal? All right, let's go see what else we got on the queue. The queue has become so big that it doesn't know how to render. Okay, there we go. All right, here we go. All right. Let's go try to choose a winner for the next question. Oh.
Let's go gambling!
No, not yet. Are we going to the admin panel? I don't need the admin panel. There we go. Choose winner. There we go.
Let's go gambling!
Just stress test it in production. What could go wrong? Hypersonic! With a 15% chance, Hypersonic, you got picked. Frickin' vibe coders. Hey, vibe coders are the reason we have this. Oh, Jesus Christ. I don't know if I can do this. Y'all are submitting some crazy questions today. Okay. Prove. What even is this, dude? What? Excuse me, what? What is this? What?
Oh, no.
I think it has to do with lighting, I believe. 'Cause I see scattering, I see a sigma, and I see a neutron. So I guess light. And I see a KX, which is usually
this is going to chat.
Yeah.
It's going to chat GPT.
DM, I don't think that's a math problem. I think that's a physics problem.
I agree. The Born approximation to me looks like quantum scattering. Yeah.
Yeah, I believe so.
I remember that from like my first year of grad school. I saw someone vibe code an app that blocks reels from Insta but keeps all the other stuff. Oh, that's dope. Yeah, it is a volume integral. It's a spherical volume integral, no? Yeah, D3x. Yeah, I agree. But then they do D3x prime. Dude, look. Oh, chat is choking. Chat's like, I don't want this.
Oh shit, not good.
Chat does not want this. Chat doesn't want the smoke. Okay. It is a different... Yes, you're correct. So I think you're doing a x versus x prime. Well, I mean, let's try to like decompose like what's happening here. Anytime I see h bars, I instantly know this is quantum. This is like this should be your first indicator that this is a quantum problem. Quantum physics. That's the only time h bar shows up. Yes, Planck's constant, correct. The reason it comes up all the time, for instance, is the energy associated with a photon is equal to h bar omega. So this is like, or sorry, h bar f. Sorry, my bad. 2 pi h. Well, one of them has an h bar. Maybe it's hf and it's h bar omega. All right, one sec. Yeah, it's h. I think with h bar it's omega. Yes, it is h bar omega. I was correct. Okay. Yeah, because the only difference between h and h bar is a factor of 2 pi. Yeah, I was correct. I was correct the first time. Okay. Yeah. So this is the energy of a photon is equal to h bar omega. And so this is probably some normalization to the energy of a photon scattering. And then I'm trying to think other places it comes up. This right here. Okay, so whenever we see this to me looks like, for instance, R, which usually refers to, in the case of scattering, I think where the thing is scattering to minus where it's scattering from. So here, let's pull up some images. Just because I can't solve this doesn't mean we can't learn. But yeah, here we go. Yeah, Compton scattering, I guess, is kind of related to it, yeah.
Yeah, but Compton's like early modern physics, I think.
Yeah, this isn't even crazy.
That was like the first or second thing that we went over in modern.
Right, so if a photon is incidental on an electron, the electron will recoil at some angle phi, and then the photon will continue on at a different angle theta. And then there's a way to calculate the change in the wavelength of the photon. The reason why there's a change in the wavelength is from this equation, right? E equals h bar omega. We can also remember that, what is it? Omega f, I think, is also equal to E, right? Or sorry, lambda f. So lambda f is equal to h bar. Actually, how do I relate this? Anyways, okay, wait. Yes, okay. This is I think what I want to talk about. No, this is v. Sorry, this is speed. Yes, that's what I wanted to say. Yeah, speed is equal to wavelength times frequency, and that's also, I guess, related to the energy of a photon, even though all photons travel at the speed of light. But if a photon collides with something else and the whatever it collides with ends up moving, by conservation of momentum, you have to have some change in the energy between these things, the two things. So the photon is going to impart some energy on the electron, which is going to cause the electron to start moving, and in doing so, the photon must lose energy. But the energy of a photon is related to its angular frequency, which is also related to its wavelength. Okay, now I remember how this works. One second. Energy of photon wavelength. Yeah, this is it. This is what I wanted to write. Sorry, this is it. E equals hc over lambda. Yeah, this is the other one. Right, okay. Watch where this comes from. It's actually, yeah, physics is fucking cool, right? Isn't it? Yeah. Okay. Right, speed, but this is equal to light, which is equal to c, right? Okay, so lambda f is equal to c. So then f is equal to c over lambda. And then omega is equal to 2 pi f. So omega over 2 pi, or wait, so omega is equal to 2 pi c over lambda. And then if I plug that into here, you get E is equal to 2 pi h bar c over lambda. And then h bar is equal to h over 2 pi, I believe. Yes, h bar is h over 2 pi. So then if you plug that in, the 2 pi's cancel, and you get that E is equal to hc over lambda. Okay, so this is the energy of a photon related to its wavelength. And so if the photon loses energy because it causes something else to gain energy, it must then lose wavelength. And that can be measured, I guess, which is cool. Scattering cross-section, I think is kind of like a probability of like where the electrons go. Oh, V Sigma, oh, is this you posting the roots thing? Oh, I appreciate that. That's cool. The Born approximation? Yeah, we can get into that next. Yeah. Okay. Right. Oh, it's perturbation theory. Yeah. Lipwinschwinger. Right, and then there's a sign in there. Yeah. And then you can use Green's function. Yeah, this stuff's crazy. Scary, crazy stuff. Scattering theory.
Math message teacher worked on perturbation theory stuff. There's a lot of like work on deriving it and
Really?
all the stuff on perturbation. Yeah, I guess I haven't had any class with him, but I'm kind of glad I haven't. But
yeah,
I guess he's retired.
scattering. They asked scattering on our quant or our qualifying exam in grad school, and it was always like one of the scariest things. I would just blindly memorize the equation and just hope I could do it.
Yeah, that's what I've been doing.
Yeah, I'm just like fuck. Yeah. Okay. Well, let's see. Did ChatGPT finally get this? I just wanted to like thought for 3 minutes. Wow. Okay. Integrate over angles. All this. Yeah. A useful identity is... What? Oh, man. Okay. Well, it can be done. I don't know if I can explain it in the course of a YouTube stream, but it is cool. And if you go into graduate level physics, you do have to do this. So maybe think about that. If you think about how bad you want that PhD, if you want to do this, it's a lot. Yeah. Cool. All right, I'm gonna call this one done. It was fun though. Hypersonic. Hypersonic indeed, dude. And then here, I will post the ChatGPT link of this one if you really want to go through it. This is one of these things that the professor says, yeah, just do it to build character. And it definitely does build character. I remember having to do this in grad school and like seriously contemplating why my life was involved doing this. But you get through it. Just you have solved this problem and earned 1 PhD. This is only just to get through the qualifying exam, honestly. It's quite crazy. All right, let's see what we got for... The cool thing with having so many questions right now is it's actually like diluted the percentages, right? So even if you submitted, again, this person hit a ninja 16 minutes ago, you have a 2% chance. You're not that far off, right, from the other people. 6%, 7%, 9%, 12%. It's a cool phenomenon. I love it. We're stress testing how the probability works with time and upvotes. Everyone is kind of hitting the upvotes, so that's kind of fun. All right, let's go choose another winner. See what happens.
Let's go gambling!
What's up, Pineapple? Lucky cat! You are a lucky cat today. What do you got for me? Ooh. We're writing polynomials? This is math, Jeff. Are you excited, Jeff? We're doing math. Yeah, Jeff's so excited. Jeff's so happy. Like, yeah, let's do it. Okay. Write the equation for the family of polynomial functions of degree 5. Degree 5 means the exponent needs to go up to 5. That have zeros at -2, order 3, and 6, order 2. Very cool. Love this. Okay. So, I'm going to put this in factored form. So, how factored form works is it's x minus what I call like the 0 to the, I don't know if I call this order. I think I usually call this multiplicity, right? I would call this like the multiplicity, which I guess is, in their case, they're calling this or order. Yeah. And then there's always like a constant, multiplicative constant. Yes, there is only one, right? Okay, so cool. All right, so for part A here, we're going to say that f of x is equal to a. A is some like random constant, I don't know. And then it's going to be a 0 of -2, so that's x minus -2, and then order 3. And then x minus 6, order 2. And then what you should notice to confirm, right, that this is of degree 5, is that if I were to multiply this all out, I would get an x to the 3rd from here. I go to an x squared from here. And then x squared times x to the 3rd is x to the 5th. Cool. So you could, I wonder if you're allowed to just leave it in factored form. I would just say it's this. X plus 2 to the 3rd. X minus 6. You are the luckiest, Pineapple, right? Yeah. X plus 2, yeah. I would write that. I said minus -2, because it's minus the 0. But yeah, you're right. Cool. Okay. 4a does not equal 0. Yes, correct. Okay. Yeah, what does it say in part B? Write a possible unique solution, not the possible unique solution. Yeah, right? There is only one. That goes through this point, -4.5, -506.2.5, and then graph this function. Okay, cool. Okay. Okay, so then for part B, what that means is, right, this is x, and then this is f of x. So we would say that -506.2.5 is equal to a times -4.5 plus 2 to the 3rd times -4.5 minus 6 squared. And then we just got to solve for a here. So that's not too bad. Love that. A unique, the unique. If everyone's unique, nobody's unique. That's kind of how this works. All right, let's see what we got. Let's do the calculator. Okay, so.
But the teacher wants it by hand.
By hand? Yeah, what I'm gonna like put pictures of my hand on.
Write it all out.
Oh man, do it by hand. Okay, 2.5 to the 3rd, and then times, what's that? Oh wait, that's negative. No, I forgot. I almost made an oopsies. -2.5 to the 3rd. The rest by T84, just graph by hand. Dude, that would suck. This one
I
I'm
wasn't
okay
even
with.
joking about the by hand. It says by hand on the, like in red writing on the question.
I think this is like enough by hand, right? Can we say this is kind of by hand?
I'd count it. I don't know.
Oh yeah, here. I'll
I'm
put
not
this.
snitching.
You're not. Snitches get stitches, dog.
You done messed up, Aaron!
Okay. Ooh, okay. You have a video on the. Yeah, it is quantum though, isn't it? Me and quantum just have like such a love-hate relationship. She did me dirty in grad school, quantum. I got like a B- in the class, and like they cut my funding for like $5,000 for like a couple months.
Surprise, motherfucker.
It was really annoying. Like I couldn't like eat because of fucking quantum. Oldest child. Okay, let's do that. Divided by that. And then divide. This is ugly as sin, dude. What? Does it come out to be something nice? No, it doesn't.
No.
Wow. Our joke war will be invertible. Okay, A equals 2.9939. Okay, so then your final equation is f of x is equal to 2.939. All this stuff. Where is it? Wait, it should be rational. The puns, dude. Y'all gotta stop with the puns. Okay. Alright, I think that's what we do. And then graph. They do say graph this function by hand, by the way. Fascinating. I think the by hand part, you can at least graph the zeros, right? That's what I would do. And then maybe you can talk about the order of the function. Okay, so let's look, actually. This is actually really cool. A in this case is positive. So some key things here, right? This is a positive function. Because the leading coefficient is positive. It's also odd because it's degree 5. So that tells you right off the bat that the function has to look something like this. It has to go, as x goes to infinity, y has to go to positive infinity, and as x goes to negative infinity, y has to go to negative infinity. Okay? Now we can kind of like plot the zeros. This is really cool. So we have zeros at -2 and 6. Okay, so right here and 6. And then what I know, right, is that, okay, so all the way to the left of this function, this is going to have to go down to negative infinity, and all the way to the right of this function, it's going to have to go up to positive infinity. What happens in between? This has to do with the multiplicity. So the multiplicity on this one is odd. When multiplicity is odd, that means the function crosses over the 0. So instead of it bouncing like this, it's actually going to cross over. And it'll do so like kind of like something like this. Okay? And then it's going to come back down to the 0 here at 6. But when it hits that one, it has to bounce up. And that's because the multiplicity is even. So that's a bounce. And again, that fits because we need it to eventually still go up to positive infinity. The only other thing you could do here, I think, is you could plot what the y-intercept is, which is going to be huge. Yeah, I would just like leave this and say like this is f of 0. So just plug 0 in, get some number. I mean, we can do it right now. Actually, not too bad. Sorry, it's 8 times 36.
Like somewhere around 100 to 120, I think.
Apparently 846, dog. Right? Because it's 2 cubed, which is 8. And 8 times it's 6 squared, 36.
36, yeah.
Yeah, it's 846.
I added them.
Yeah, she's massive. Nice explanation, thank you. I can finally explain something today that's not like Fresnel integrals or something. Okay. Cool. All right, Pineapple. Great question. That was fun. I enjoyed it.
Well done! Well done!
Wait, put in the negative 4.5 point? No, I'm not doing it.
Surprise, motherfucker.
Dude, that's gonna be way down here, dude. We're gonna have to go down to China.
My magic trick is you just draw a dot somewhere and then
Just
put
draw a dot.
a coordinate
Yo,
point. Yeah, you just put a coordinate point on it and call it a day.
Yeah, just be like, yo, don't worry about the axes. These are not the axes you're looking for. All right, cool. Good question, Pineapple. You did get lucky today. You're very welcome. Okay, we got 26 minutes left. Let's go do some more. Lucky cat, and wait, there's another person who... Unlucky dog? Oh, Jesus, what is this? Oh, man. Okay, I hope I don't get this question. All right, let's go choose a winner.
Let's go gambling!
DM's Raid Shadow Legends. You've cleverly managed to... Dude, what are you talking about? I definitely did not avoid the easy questions at the beginning of this stream. For sure not. Oh, beautiful. Love this. This is so nice. This feels like a relaxing bath. Oh, dude, that would be hilarious. Oh, I love that, Zach. The oh, dang it. Yeah, when I get an analysis problem, that's actually really great. Yeah. Oh, wait, one sec. Let me write that down. I'm gonna write that down. That's a great idea.
I think you should make the bot, whenever it sees an analysis problem, instantly at Narosky without like anyone having to do
It just
anything.
automatically detects it, and it's just like, yep.
Yeah, just instantly adds him and then.
Yeah. Thanks for the follow, Broken pH Meter. I searched chemistry and you found my stream. Nice. Welcome. Yeah, we do chemistry. I was doing what did I do today in chemistry? We did energy levels for like electrons. Yesterday, what did we do for chemistry? Someone asked a question about, yeah, like some Lewis dot structures. Yeah, this was some chemistry. Hybridization, yeah. Yeah, if you want to ask a chemistry question, Broken pH Meter, the website to do it. Yeah, we love chem. Jeff just doesn't like chem.
Disqualified.
Can I spell submit today? I have a stroke. All right, there you go. Yeah, that's the website for submitting questions, and they get added to the queue. There's quite a few questions in the queue, but not to worry, it's random. And the chance that your question gets picked is based on how long it's been in the queue, and also how much you smash that upvote button. I'm looking to go back to grad school. I'm a bit rusty. I can respect the stream. Thanks, man. It's not just me. We also have a lot of other really awesome people. So if you go to the website where people are submitting questions, click here on streaming schedule. That also has a calendar of the other people who like stream and do sick stuff. So Zach, E2iPie in our stream right now. Penn Center does stuff, and then JC does a lot of chem actually. If you want to join our Discord as well, there's a link there. We have some really smart people in chem. I know like chem 1, chem 2 basically. OChem's where I start getting hurt. Okay, select all distribution shapes for which it is most appropriate to use the mean. We'll definitely not skewed. Right? We don't want to use skewed. Bell shape. Yep, we like bell shaped. Yep, that one's cool. Bimodal. Nope. Yeah. So maybe let me draw what each of these distributions are, so you guys can kind of see what happens. So a skewed distribution would look something like this. Wow, thanks for the sub, dude. At tier 3, I don't think I've ever had anyone subscribe at tier 3. Damn. Thanks, brother. I appreciate that. It's the first time for everything. I gotta go make some like cool tier 3 like perks. Maybe I make a perk that you get like instant like boosts on the question queue. That would be a smart one, right? Yeah. Right, so this is skewed, and the reason why this doesn't work is that the mean ends up being like here, whereas like whereas the median would be like here. Exactly, right. So bimodal, bi means like two, like bicycle. This would be like a bimodal distribution. A lot of times test scores are bimodal. Like people either do really well or they do really, really bad. So, but the average of a bimodal distribution is in the middle. So that's not a very accurate representation of like the class. Bell-shaped is great. We love bell-shaped.
Oh, yeah.
That is something that looks like a beautiful, nice little Gaussian. Symmetric. I don't know about that actually. Wait, isn't technically a bimodal distribution symmetric? Yeah? Symmetric just means it's, I don't know, like symmetric. Like it's a mirror image, right? But I mean, it could be a really bad mirror image. Right? Yeah, so I don't think it's that one. No. I don't think you can use this one. Because I think this is also like bimodal is technically symmetric. And then, but uniform, I do agree, is also okay. Uniform is where you have equal probabilities for everything. And that's, I think that's cool. Yeah. Yep, there's a Discord too, yeah. See if it works, Broken PH. I hope it does. You don't think bimodals are necessarily symmetric, but they can be symmetric, right? You know, we could do. We could ask chat. Let's go ask chat. Let's go see what our AI overlords think. Narosky, yeah, can you loan another year?
Oh shit, not good.
Loan another year. Chat's very safe. I think it's generally pretty safe with these types of questions. Yeah, it's okay. I'm just getting a second opinion. You know, like when you go to the doctor, they're like, nothing's wrong with you, or like everything's wrong with you.
Surprise, motherfucker.
You go to another doctor, see what they say. Oh, okay. So yes, they like symmetric. Okay. They say mean equals median equals center. Good summary. Chat agrees with you. I'm gonna say like, wait. Can't a bimodal distribution be symmetric? I'm gonna debate. Oh, it says great catch. Oh. Okay, so it still says it though. Okay. All right. If it was symmetric and bimodal, then no. But if it's just symmetric, it's okay. Okay. All right, ADE. Yeah. Ask your teacher. I'm just curious. Okay. For which distribution, for which shape is it usually appropriate to use the median when summarizing data? I think everywhere, right? Isn't the median always great? The median is the most resistant to outliers. Not so, I mean, is anything appropriate for skewed then? The mode, I guess, right? The mode. Because that's where most of the data is. The median is more resistant, but it's not like, it's not impenetrable. Yeah. Okay, again, we can also ask. See what chat says. Totally okay to ask for help. I think you use the mode. Oh, sorry. Yeah, that's what I meant to say. Sorry. Yeah, wrong one. Oopsies. No. Yep. Wait. Oh, interesting. Chat says to only use it when it's skewed. Fascinating. So I guess you always want to use the mean, unless you can't use the mean and then you want to use the median. Fascinating. Okay. So I guess you do want to use this. It is this answer. Wow. I mean, again, use AI like critically. I'm thinking about this. I understand its argument. I think that's the most important thing, if you understand the argument. I understand the argument they're saying. They're saying that, like, you should use the mean, but if you can't use the mean, use the median. But the mean is better than the median. Okay. The number of writing instruments in some teachers' desks is displayed. Which is greater, the mean or median? Explain your reasoning using the shape. Right, cool. All right, great. So this has outliers down low. So we would say this is skewed left. And when things are skewed left, the mean is going to get pulled down further to the left. So this would be the mean. I don't know, like this right here would be the median. And I would say the median is greater. Yeah, and if you want to like see like there's a cool little diagram for that. Mean, median, mode, situations. I think I want like skew. This is what I want. Can I get a better image of this? It's okay, I guess. Yeah, so here it is. So when something is skewed left, yeah, you could just say like skew left. This means low outliers. Pull the mean further down than the mean. Than the median, sorry. Yeah. That's the explain your reasoning. Dr. Gold is slowly becoming the human version of ChatGPT. Yes, maybe I am Leto 2 Atreides, and I am becoming the sandworm. I'm letting the... What are they called? There's a name for those fish. What is it? What's it called? What are the fish in Dune called? You know what I'm talking about? Scalefish? Sand trout! You're a man of culture, Broken PH. Thank you. Yeah, the sand trout. Yes. I'm slowly letting the sand trout encompass me. And the sand trout is using ChatGPT. I love Dune. Great series of books. Okay, cool. Great question, DMs. Yeah, Fembox is here.
Well done.
Alright, we're gonna mark that one as done. Which means it's gonna go into the Discord. There it is. And then let's drag it in. There you go. So cool. There's a link to the problem we did, and then there's a screenshot. Sensation! What's up, brother? Welcome back, Sensation. I haven't seen you in a hot minute. Sensation's one of our OGs. OG mod. Good to see you, Sensation.
Good job.
Imagine not knowing the meaning of the word avatar. That film is trash, honestly. Every time I see it, it's like, oh man, it's the same thing. All your times are screwed up. Yo, Sensation, I'm gonna be in the UK in like May. I gotta go to a wedding in Killarney on like the 27th. So I'm gonna come to England. Maybe I'll come like up to a little bit North England for a bit. The YouTube has like a 15-second delay. Yeah, YouTube. Yeah.
Surprise, motherfucker.
Anyways, good to see you, Sensation, dude. Feel free. Always hit up my DMs, dude. I think I tried to DM you recently, but it wouldn't let me. You have like some permissions set that we gotta be friends. But I accept your friendship. My generation knows the word avatar. Oh, from System Shock 2. Ooh, wow, yeah, System Shock. That's an old school game. All right. I got, how many minutes I got left? I got 10 minutes left. I think we can do a couple more questions. Let's do it. Let's choose a winner. Who are we gonna get?
Let's go gambling!
Crazy Gamer!
I think I looked at this one. I don't think it's good. Oh no, I was thinking of a different one.
Oh man, it's funny because I recognized the name. A potential benefactor just followed. Who's a potential benefactor? Oh, Rich Dope 174. Yeah, Rich and Dope. Those are two nice things. Oh, they re-released System Shock 1. I love when they do like the remasters. I want them. I need to go play Half-Life 1 again, remastered. That was a great one. Purcell and Morin, yeah, okay. Consider two oppositely traveling electric field waves. The sum of these two waves is a standing wave. Excellent, love. Find the magnetic field associated with this standing electric wave by finding the B fields associated with each of the following traveling E fields, and then adding them. I want to say that it's like B equal to like curl E. Is that how this works? Maxwell's equations, I know somewhere. Yes, come on up, Sensation. Come on up, dude. What's cracking, dude? What's the crack? Test. What's the crack? Hello there. What's up, dog? How's life?
Oh, you know, it's like 10th gnar.
10th gnar. You know, the other person I miss is I haven't seen Noyce in forever. I hope he's okay.
He'll be at uni now, won't he?
He should be at uni. Yeah, he accepted like an internship or something, didn't he?
Not as interesting as it sounds.
Well, I just remember he was going down the train of you know, going to parties and like getting a little too fucked up, and I was like, no, Noyce, stay in school.
That's true of everyone in this country, though, from the age of 12.
I guess so, right? Yeah. Especially if you're like closely related to like the county houses and stuff, or council homes.
Yeah,
sorry, that's what it's called.
Yeah, council estates.
The council.
As soon as you're
states.
12, it's like let's go to the park and drink cheap wine. You know.
Oh God. Boone's Farm, all that stuff. Nice. All right, let me see if I can do this in 8 minutes. You want a B field, right? Someone wants a B field. So curl E is equal to negative dB dt, yeah? So if I take the cross product of this, and this is only in the x hat direction, that's going to put things in the, oh man, I think the y and the z direction. I think this, one sec, I think this is how this works. So this is ddx, ddy, ddz, and then this is going to be just E, because E is only in the x direction. So we're going to just say E1. And then this is going to be 0, 0. And then, oh, actually, no, I fucked this up, dude. One second. This all comes down. There we go. X hat, Y hat, Z hat. Love. Okay. So if I do my cross product, this is going to turn to 0. This is also going to turn to 0. I think. Wait, no? No, it actually doesn't turn it. Sorry, this part turns to 0. But I'm going to get minus this, but also, because there's another minus. So I'm going to get ddz E1. That's in the y hat direction. And then this is going to be minus ddy E1 in the z hat direction. X hat, y hat, z hat. Yep, first. Yep, got it. Nice. Okay. And then, but these only have components in the z this only varies in regards to z. So ddy is 0. Nice. Okay, great. So now I know this. This is Zed's dead. Zed's dead, baby. Yeah, that's a great movie. K E naught. K E naught cosine. Wait, sorry, no. I gotta make sure I don't mess this up. Sorry. Derivative of cosine is negative sign, so it's K. K comes out. Ooh. And then this is sine. And then this is KZ minus omega t. Yeah, I think that's right. And that's in the y hat direction. Cool. And then, I think the other one's going to be the same then, no? Right? Because, yeah, I don't care with regards to omega t. It's also in the x hat direction. So wait a minute. Ooh, okay. So this is E1. So this is, sorry. This is, that's dB dt1. And then by the same token is negative dB dt2. dB2. Yeah, okay, good. All right, fine. Okay. So they're actually the same, no, right? Yeah. So, okay. And then if I add it up, for instance, like E1 plus E2, right? I'm going to get twice that. Yes. The sum of these two standing waves is that. Okay, oh, but they want us to find the B fields associated with each of the waves and then add them together. Okay, that's fine. Okay. So this is dB1 dt, which is also equal to... No. But then dB2 dt is equal to negative k E naught. And then this is going to be sine kz plus omega t. All right, kz plus omega t. And then I think what I want to do is I want to integrate with respect to t, right, to get b1. So then integrate. So db1 is equal to integrate, and that's going to be negative k E naught sine kz minus omega t dt. And then let's write the same one for this one. Yes, and this is plus. Okay, cool. Got it. Okay. So then when I integrate, I'm going to get that b1. Integral of sine is negative cosine, so that's going to pull that out. But then with the dt, that's a chain rule that pulls out a divide by omega, and it's a negative as well. Oh, there's so many negatives. Okay, so this is k over omega E naught cosine kz minus omega t. And then b2 is going to be... one sec. Minus. This one's minus. This one's positive. Yeah, okay. And then this is k over omega E naught cosine kz plus omega t. And then plus c, but I think we just assume like some sort of boundary conditions. Okay. So then the B field, B total, equals B1 plus B2. That's going to be equal to K over omega E naught. And then that's going to be cosine KZ plus omega T minus cosine KZ minus omega T. And this may be a trig identity. It's like cosine of A plus B, cosine of A. One second, ask AI. Simplify. Cosine A plus B minus. Is it minus? Yeah, I think it's minus. minus cosine A minus B. Let's see what we get. Ask AI, always right, yes. And it is. Okay, look at that, because it's -2 sine A sine B. Look at that, look at that. Oh man, that's so cool. Yes, it is an identity. I'm running out of time, and I want to make sure I just do this. Yeah, my bad. There we go. That's what we have. Okay, so then this is K over omega E naught, and then there's a -2 out front. I trust AI more than I would trust... Dude, you can't trust anyone these days. Okay, this is sine KZ sine omega t. Which, is that what they had? Well, they had the electric field was cosine KZ cosine omega t. So I think this kind of makes sense for the magnetic field to be sine. And then this is also all in the... this is all in the y-hat direction. And that makes sense, because electric field and magnetic fields are orthonormal to each other. Yeah. Okay. Find the magnetic field instead by using Maxwell's equations to find the B field associated with just that. Oh, okay. I think that would be doing this again. Which... Well, I mean to answer a math question, not to give life advice. Oh, yeah. Okay. I think this would be... that's going to be the same thing. We're going to do... Because this is only in the z direction. Sorry. Only in the x direction. So this would be ddz of 2 e naught cosine kz cosine omega t, and then this would be equal to negative dB dt. So when you take this with respect to z, this is the only thing that has z in it, and the derivative of cosine is negative sine, so you get -2, and then you're going to pull a k out. 2k e naught sine kz cosine omega t, and that's equal to negative dB dt. Negatives are going to cancel. And then we integrate this with respect to time. This is the only thing with time on it. So you get 2k e naught over omega, and integral of cosine is negative sine. No, it's just positive sine. So we get sine kz sine omega t. And then that's also going to be in the y-hat direction. Is that the same thing we got? Off by a minus sign.
Oh shit, not good.
Damn it, where's that minus sign come from? One sec. Derivative of cosine is negative sine. Yep. Integral of cosine is sine. Ugh. Why am I off by a minus sign? Bond coins? Bond coins are how you... Every time you do things in our server and also ask questions here on the stream, you get points, and those points convert into... We buy gift cards for people, like video game stuff. Pesky little negatives. Yeah, I'm going to just say that, you know, off by a negative somewhere, you know, don't get too mad at me. Maybe ChatGPT was wrong. Yeah, let's just go with that. I think so. Yeah, a plus b minus a minus b sine a sine b. Dude, heresy?
Disqualified.
Okay, unfortunately I do have to go pretty soon, so okay. I'm gonna say, like, check the minus sign somewhere. There's a minus sign there. But otherwise, Maxwell's equations are not a lie. And I'm gonna consider this one done. Okay. How dare you question the great ChatGPT? I know. Absolutely terrible of me, Zach, right? Okay, great. Whose question was this? Crazy Gamer. This was fun, actually. I love E&M. I'm teaching E&M this summer at UCLA. So, if you guys want to tune in over the summer for that, I will be streaming it. It'll be fun. Okay, cool. All right. Yes, I think it was good. Yes. Great. Awesome. Cool. Let's close out the stream. All right. Thank you again, everyone, for coming to Actual Education Office Hours today. Appreciate all the questions. Yeah, thank you all for being here. Yeah, it's super awesome. We had so many questions today. Holy shit. You guys were on top of it. Yeah. So for the 11 other people that submitted questions, do not worry. Everything here gets put into our Discord. And there, either other people in my community will solve it, or if you wait around 2 days, we have a bot that'll go through and just solve them all, with AI to at least like give you guys like a hint. So cool stream to stumble on. Thank you, Broken. I appreciate you being here. Welcome to the community. I'm not the only, the wheel was so colorful. It was so colorful today. Yeah. I appreciate all the questions. But yes, so make sure to go, if you found us on TikTok, or if you found us on YouTube, or you found us with someone else, go check us out on Twitch. Give us a follow. That's the best way to watch. It's horizontal. It's nice. We rate other people. You can join our Discord here. And then also, if you want to see the schedule, these are all the other times we're streaming. I usually stream tomorrow, but I have to go debate a flat earther for a pretty big YouTube channel. It's gonna be hilarious. But I will post the link to that when they post that. So that's gonna be funny. So to make it up for you guys, I am gonna be doing a stream on Wednesday. We don't usually stream on Wednesdays, but come on by. That'll be fun. And then also check out all the other awesome streamers we have. We have Math Pond, we got Penn Center, we got Zach. Yeah. Flat Earth debates. I know. Yeah, I'm kind of, a lot of people have told me not to do this. But they're paying me a lot of money. And I'm always open to debate with people, no matter how crazy their opinions are. It's a trap. Yeah, it probably is a trap, honestly, but what do I care? Like, what? If there's anything I've learned from the media these days, there's no such thing as bad press. You can do literally anything. As long as it's press, it's press. And I'm going to attempt to, you know, impart some knowledge and sense into people, so it's okay. All right, we're going to go raid someone. So if you're following us on Twitch, which is a great channel to be on, please go ahead and say hi to whoever we raid. Who are we going to go raid today? Who's on? A lot of people on. Let's see. Moo Hoodles. Go say hi to Moo Hoodles. She's great. Yeah, she does, like, astronomy stuff. I'll tell her I'm going to debate a flat earther, and she may get, like, really upset.
You're not that guy, pal. Trust me. You're not that guy.
And anyone in like the science and whatever community I've talked about doing this, they're like upset that I'm even giving the opportunity for someone to speak about it. And I'm just like, that's a really negative way to go about the world. Like, we should listen to people, even if they're crazy. Anyways, okay, cool. All right. Enjoy the start of your week. We will see you on Wednesday. Peace.
I posted that in Discord, friendly reminder.